I see a classmate asked. Are EIGRP adjacent routers neighbors? Yes. The device will only exchange packets with its current adjacent router. Actually, the same is true for OSPF. Must be a neighbor. Otherwise, there is no way to exchange messages. We'll wait while we make the announcement. The device needs to declare the directly connected network segment between it and its neighbors. So the device and it must be connected. Otherwise, they are not in the same network segment. There is no way they can be built like this. If they cross network segments, the two of them will not declare the same network segment at all, unless they are connected like this. Let's look at this topology table. Before this, I need to open up the experimental environment we did today. Otherwise, there may not be enough time for a while. Okay. There are several parameters in the topology table. For everyone to understand, we just look at this 4.4.4.4. Because wait a minute, we do experiments and we do it. In the topology table you will find, when data goes to a destination, there will be multiple next hops. And there are two parameters in the next hop. You will find that these two parameters are not the same, but they all appear in the routing table. So we're going to talk about something today. Let's look directly at this picture. This diagram is very simple. There is a loopback port on R4. The address is 4.4.4.4. That theoretically, there are two ways for R1 to go to 4.4.4.4. That is, the upper and lower roads. But please be careful. We're talking two ways to get to this address. But not necessarily these two paths will appear in the topology table. This is different from what everyone thinks. At the beginning of our study, we may feel that. How many ways to go to the destination? Put these roads as backups in the topology table. Not like this. Appearance in the topology table is conditional. It does not mean that there are several roads that can appear in the table, but both routes generate a topology. That's right. But not necessarily into the topology table. Whether it can enter the topology table or not, we can distinguish it according to its commands. First, type show IP igroup topology on your command line, called all links. If you enter a command like this, if you add all links to the command, then as long as there is a line from the originating node to the final node, as long as there is a physical connection, it will appear in that table. But if you enter the command without this all links, then there are only true topological lines will appear in the topology table. This is a real topology table. This is called the physical wiring list. That is, you can see all the lines. There may be many routes to the destination, but they do not necessarily all become the contents of the topology table. For some next hops that do not meet the conditions, won't put it in. Okay. Let's look at the routing table next. Here is a command. Show IP route igroup. Do you know what this means? When we check the routing table every day, it is show IP route. Now there is an extra igroup in the back. Just look at the routes learned from EIGRP. If there is an extra OSPF behind, just view the routes learned from OSPF. EIGRP starts with D. So here we have a question. There is a problem of managing distance in the back. When I talked about managing distance before, I told you administrative distance is actually divided into internal and external. EIGRP administrative distance inside is 90. External is 170. What does this external administrative distance mean? I give a simple example. For example, Here are two devices. Both devices are running EIGRP. Then the internal administrative distance is 90. Here is a network segment. There is also a network segment here. Suppose this is the 1.0 network segment. The right device learned 1.0 on the left device. In its routing table, 1.0 the administrative distance of this routing entry is 90. But if one day, there is a device here, the interface of this device and the interface of the left device are up by OSPF. Both of them are running OSPF. Agreement changed. Assuming this has a network segment of 2.0. Although here is OSPF. Here is EIGRP. But I hope the device on the right can learn the 2.0 network segment in OSPF. So how to learn it? They are not running a dynamic routing protocol. I just said different routing protocols are running between devices. They cannot directly exchange information. We have a method. Redistribution. I can redistribute. Then on this device, put the content in OSPF. Introduced into the root of EIGRP. This is called redistribution. Also known as routing import. Then now, it will be passed to this device of EIGRP. This device will learn the 2.0 network segment in OSPF. But for this device, it is also learned through EIGRP. But it is learned via EIGRP redistributed incoming routes. Then this administrative distance is 170. Finally, here is a summary. You may not be able to learn this at the NP stage. Might learn it in IE. Don't need to understand at this stage. And this value will not appear in the routing table. It is an implicit. As for what it is for, we can't get involved now. So you just need to understand the inside and outside. We are still talking about the interior. Now there is no redistribution involved. This is what is covered in advanced courses. Let's move on. Update multicast address. That is, when we use EIGRP, the multicast address it uses is 224.0.0.10. This needs to be remembered. By the time we learn about OSPF, that's 0.5 and 0.6. It uses 2. EIGRP uses 1. 224.0.0.10. And the protocol number is 88. EIGRP is encapsulated on top of IP packets. There is a protocol field in the IP packet. If it refers to 88, indicates that the upper layer uses the EIGRP protocol. If here is 89, indicates that the upper layer uses the OSPF protocol. You just need to know this. Don't ask you to remember it. Okay. Next we will learn the algorithm of EIGRP. The algorithm of EIGRP is called dual. The first is the acyclic path. This thing you will learn in the NP stage. Because this involves how the algorithm draws the topology. We can't get in touch at this stage. Because it is more difficult. What we have to learn is the alternate path. Fast convergence. This is the core of what we are now explaining. A loop-free backup path is, if the data has 2 lines to the destination, the above route is the best. The optimal one must be added to the table. There is no doubt about this. Then the ones that are not so good will not necessarily enter the topology table. Is to be considered. Wait a minute and we'll figure out how to calculate it. If there is a line